So hi everyone and welcome to our next tips and tricks clip once again regarding singularities. As we've already learned in the last video, singularities can occur at nodal and line supports as well. And with that, such effects also influence the structural design, which is why we have to take care of this during the modeling process of a structure. I'd like to illustrate this with the following example. We can see here two concrete slabs, and if we display the results, we can clearly see that the required reinforcement, especially at the nodal support, is too high compared to the other model. And the reason for this is we have here a typical singularity caused by, we can say unrealistic support conditions, meaning the support here is too rigid, resulting in a stress concentration at this point. And in reality, this does not occur in that amount. So how we can avoid those singularity effects? As a tip, when creating such structures, we can define elastic supports instead of fully rigid ones. And for nodal supports, we can use the option called column in Z, meaning in Z direction. We can enter the dialog for that by double-clicking on the support, and here we can find this option. So if you select this checkbox, a new dialog will show up. And then for defining this kind of supports, there are basically three options. The first one is called elastic surface foundation. The second option is an elastic nodal support. And there is a third one, which is a nodal support with an adapted FE mesh. So what's the difference between these options, or what does the program internally do? If we choose surface foundation, the surface of the column with the defined dimensions is cut out. And then we basically have here an elastic surface support, and the spring values are calculated automatically by the program. If we choose elastic nodal support, the surface of the column is cut out as well, but supported at one node. So here the support is modeled as a nodal support, as the name suggests, but with a translational and rotational springs, which are again calculated automatically by the program. In addition to consider the higher bending rigidity, the surface thickness is getting doubled by the program internally. For our example, let's say we choose the first option, and then down below we can enter the dimensions for the column, for instance 300 by 300 millimeters. Next we can select the material and define the height, which will be, let's say, 3 meters. Additionally, we have here the option to select the support conditions, whether it's a hinge one or a semi-rigid or a rigid one. Next, we can click OK through all of these dialogues. Now we can see in the model our defined support. We will change the second support as well by double-clicking on the support and then simply choosing the support type that we've just created. We can display, if we want to, the dimensions of the column. We can do that in the display menu. If we expand nodal support, here we can find a column. And now we can see the column in our model. So for line supports, in case if we have a wall under a slab, or if we create, for example, not a 3D but a 2D model, where walls under a slab are commonly modeled as line supports, and again this causes also singularities due to too rigid support conditions. And for that we can also use elastic supports. All we have to do is double click on the line support and then choose, instead of column in Z, we can find here wall in Z. Similar to the nodal support, we can enter the dimensions, for example 250 millimeters and 3.5 for the height. Next, we can select material and support conditions. On the right side here, we can then see the calculated values for the spring constants and then click OK. We can also get the dimensions of the walls displayed under the line support and then choosing walls. And after that, we can calculate the structure once again. With that said, thank you for watching. If you like this video, don't forget to like and subscribe. For any questions you may have, you can leave a comment down below or visit our website luba.com.